Hey, hi. Today, actually, I'm going to explain about the a stack basically with middle operations, a stack implementation with middle operations. So, thing is that how we will perform the middle operations in the stack. So, push and pop is always it will be act like as usual, uh, and main thing is that how you will apply the middle operation, how you will always track that what is the middle operations, middle element of the node. So for that nothing but we will maintain the what is our head and what is the middle basically. So whenever it will be applied to delete the middle element, then we will remove the element and then after that we will add. Okay, so removing the node into the linked list, I hope you know very well. So there will be the basically this five operation which I am going to do it, but more specific that how we will delete the middle operation. So that let me explain. First thing is that whenever you will push the data and pop the data. Okay, so in that case, whenever you are pushing the data, like example, I think that in the beginning it will be the linked list is the null, so your head it will be this one. Okay, and middle element is also itself this is whenever you're pushing the data, right? So during the push the data, this is the only the middle operations. Now suppose that next data is comes. Okay, and you also maintain the what is the size, since size equal to 1, after the adding the middle of one element, then after that next data it will become, then what will happen, size is become the 2, and then after that we will create the one new node. First we will create the new nodes. Okay, and first we will create the what, we will create new node, we will create, sorry, not this size, yeah, sorry, actually I saying first we will create the new nodes here. Okay, and then what we will do, since size is it become the 2, middle is there, so you know that always the addition will be happen at the top. Okay, like this. So it means that whatever the new node is there, this new node of the next belong to the head. Okay, and similarly whatever the, if there is a double linked list, then head dot before equal to this new node, whatever the new node is there. And since middle is still here, right? So middle is here, so it means that if there is the, and size is equal to 2, so you cross this. Now you keep head equal to this one, this is to become the new head. And middle operation, if the size is, if this node size is the 2, so in that case middle also it will move to the middle of before, right? Middle of before equal to what, middle dot before equal to here, right? So this will be the middle. Now again you think, now think that again I am pushing the next element, it means that here I am adding again the same operations. We will create the node, we will operate this one, this is, and head in this case, again the head what it will become, head will be this here. Okay, but since it's a odd, right, 1 2 3 nodes, so still middle will be here only. Okay, so I hope so you got it. During the push, again the same thing whenever we will apply the pop operation. Okay, so pop means what, pop is always, deletion is always happen from here, right? So in this case, since deletion is happening always at the top, okay, so it means that if it is happening at the top and our head, okay, so what will happen? First is that size minus minus we will do, and here it will become the this head, it will be go at the upper level, okay, this head it will be go to the upper level, it will be go to the upper level here. And again this, since node we have to delete, so it means that their link itself it will be nullified, head dot before equal to null, and this element itself is nullified and maybe return it. So in this case it will be 2 only. Now let's discuss with the deletion of the operation. So deletion of the operation, middle element. Now deletion of middle element is also almost similar. In the deletion of middle node will contain the three condition basically. Suppose that this is the linked list, okay, means is nothing but it might be the so top is here, right? So either this middle element, there will might be the three condition, either the this middle element itself is the head at as per this node, this is the middle basically, okay, but there might be the, if in the generic form we will discuss, then there might be the three things. First thing is that either the given linked list or given a stack itself doesn't have any element, then in that case we don't have to delete. Second condition is that only one element we have, so only one element we have, then it means that, and this element itself we are deleting in one element, then it means that we have to nullify the head element equal to null and return this data basically, okay. uh, this is the one condition. There might be the condition that key middle equal to this one, but it have the two node, right? It have the two node, so in that case we will delete it and head it become this one, okay. Means middle of next, middle will move to here, okay, middle move to here, middle dot next, and head equal to also move to the head dot next, okay, and it will return the data. Now condition third one, it might be the even node greater than 2, okay. So in that case, suppose that you have the like middle operation somewhere here, right? Like example, as you have the 6 node, so your middle it will become here. So it's nothing but more or less how you are going to delete this node, right? And this link you will do it, and next element, next middle will become this one, okay. Middle this it will become the middle operation, right? Third condition is that if there will be the even, there will be the odd, like this is the odd element. So in the odd element also, what we will do, in the odd element middle operations, you will perform that again. There more or less it will be you have to delete these operations, and during the deletions, what you will do, middle equal to middle dot next, okay, and you will capture this one, so this you link to this one, and this you have to link this one, and if the before dot next not equal to null, then before dot next equal to this one middle, nothing but, so you will return the data, okay. So let's jump into the code. So coding wise, coding wise, let's into the fast track we will go. So here, like I explained, this is the push operation which I am doing. If there is a no any node, then just creating the node and initializing the head and middle is the same. If more than one node, then in that case just adding the data at the tops and incrementing the size. If the size incrementing the size, if the and just adjusting the middle here. Adjustment of the middle during the push is happens based on the mm, size equal to even. Okay. Similarly, pop, whenever the pop is happens, here the adjustment of the middle operations middle is happening based on the odd number. Okay, so if there is a odd, then middle equal to middle dot next it will become, right, after the deletions, if odd element will be there. Okay, so and again the here is nothing but we are performing. So here if you will see, this is the data with three condition which I was explaining, that how we will modify our middle operation, right? So I hope so you got it. These are the three operation which these are the three condition which need to take care whenever we are going to delete the middle. So like that, this is one of the famous interview questions which many product companies ask. Thank you. Bye.